Alright, so we're going over the review worksheet, and here's number, what is this, 24? So it's number 24. Alright, it says find this when this is true. So what we're going to do, this is what we're plugging stuff into. Actually, I'm sorry, it's the other way around. Yeah, let's not do that. Because if you think back, like to the easy ones, it would say, what, find like g of 2 when like g of x equals, 3x minus 1 or something, okay? I just made that up off the top of my head, okay? So watch. If it said find g of 2 when g of x equals 3x minus 1, what would you do? What would the substitution be? It would be taking 2 and doing what to it? Putting it in for x. Does that make sense? Okay. So what are we going to do here? This says what? Find this stuff when g of x is x squared minus 2, right? So let's see what we're going to do here. So that means we're going to take this stuff, we're going to take this and do what to it? Plug it in, right? Right? The other problem said g of 2, right? So what do? We took that number and plugged it in for the x here, didn't we? So what are we going to do with this? We're going to take this and plug it in right there for that. And then we're going to put a minus, and then we're going to take this, and then we're going to plug it in for right there. Does that make sense? Yeah.
Why would it just say g of x then?
Because you're just subtracting this whole thing, because it really doesn't change it, right? Putting an x in for this doesn't change it, but it keeps it x squared minus 2, because this is g of x, isn't it? So you're taking this, when you plug it in here, minus g of x, which is this whole thing. So let's plug it in and we'll see. So what we're going to do is we're going to take this, x plus h, and we're going to plug it in right here. Okay? So what does that tell you do? If I take this and I put it in for here, it says whatever you're plugging into it, what are you going to do to it? You're going to square it, and then you're going to subtract a 2, correct? Because, again, just replace it with g of 3. What if it just said, like, g of 3? I just made that number up, okay? What if it said g of 3? What would you do? You would put a 3 in for the x, and you go 3 squared minus 2, wouldn't you? If it just said a number? Anybody following me or not? I'm getting blank stares from you guys. I don't know if that means you're understanding it, or you're just not responding, or you don't understand it. I don't know. So what if it said find g of 3? What would you do? You'd take a 3 and you'd plug it in for this, right? 3 squared is 9 minus 2 is 7. But it doesn't say 3, does it? It's not that easy. It says this, but we're still plugging this in for this x. So I'm going to go x plus h squared minus 2. Now what else does it say? It says minus, so we put a big minus right there, g of x. Well, what's g of x? It's this whole thing right here, x squared minus 2, isn't it? But if I'm subtracting x squared minus 2, am I just going to put x squared minus 2 here? No, I'm subtracting the whole thing, aren't I? So I'm subtracting this whole entire g of x. So I'm subtracting that whole thing right there. It has to be in parentheses. So I'm going to go x squared minus 2. Yes? No? Maybe? Right? I mean, technically, yeah, I did take this and substitute it in for this, but it didn't change anything, did it? Because if I put an x in for x, it stays the same thing, right? It's still x squared minus 2. So it's just a substitution. I substituted two things. It's just, I don't know if this helps or not, but it helps me think about it. It's just like saying this, g of 3 minus g of 5, right? What if it said this? What would you do? You'd put a 3 in for this, right? So it'd be 3 squared minus 2 minus what? Put a 5. 5 squared minus 2, right? But it's not a 3 and a 5. This is like my 3, and this is like my 5, right? So I put the 3 in there, right? There's the 3 squared minus 2 minus what? Put the 5 in there. 5 squared minus 2. Alright, I don't know if that helps or not. It does help me, though. It helps me kind of visualize. Just makes it a little simpler, and then saying, oh, it's the same thing. It's just a little weirder looking. But now you have to do some algebra with this. I'm going to go through this really quick. So this is going to be x squared plus 2xh plus h squared. I just FOILed that. Minus 2. Distribute the negative. It's minus x squared. Distribute it to plus 2. And now you just add some like terms. X squared minus x squared goes to 0. Negative 2 plus 2 goes to 0. There's my answer. 2xh plus h squared. So once you knew what to plug in where, it wasn't half bad, was it? I mean, this thing right here, you had to FOIL. I just did that in my head. Right? X plus h times x plus h. This is not x squared plus h squared. I've said that 3 dozen times this year. I don't know exactly that, but I've said it a bunch. That you can't distribute an exponent through here. Alright, that's all I can say about that. What'd you say, number 3? Alright, let's take a look at number 3. It says, find the domain and range of this thing. Goodness, what's going on next door?
They're making something explode, is my guess.
Is that what it is? I don't know, it just sounds like they're marching around the room or something, or dribbling a basketball. Sounds like throwing furniture. I don't know. Let's take a look. Find the domain and range. So we need to find the domain and we need to find the range. Remember what the domain is. The domain is the x, right? What is my restriction for the x? Can I put in any x in the world for this right here? Almost, except for what? 3. I can't put a 3 in. Why can't? Because 3 minus 3 is what? 0. Can I divide by 0? No, I can't. But I can pick any number. I can pick a negative number. I can pick a positive number. I can pick a really small little fraction or decimal. I can pick a big humongous number, right? I can pick any number I want, and this will still be a real number, except for 3, all right? Because 3 would make this into a 0, and I can't divide by 0. So how do we write that? It's every single number except for 3. So if you want to visualize it, think of this. It's any number that's positive. So we cannot include 3, correct? So we don't put a bracket here. It's every number that's positive, that's bigger than 3, and it's also every number that's what? Smaller than 3. The only thing it cannot be is what? 3. So look at my interval notation. It goes from negative infinity to 3. But do we include 3? No. How do we show that we don't include 3? Parentheses for open. And you can also have everything bigger than 3, correct? But it cannot include 3. That's why we put a parentheses there. So it's 3 to infinity. And that's your domain. Got it? So x can be any number in the world except for 3, and that's how we write every single number in the world except for 3. Look at the range. What about the range? Now, once we do pick a decent number for x, one that will work, any number but 3. I can pick any number in the world except for 3. Once we do that, what about my answer? What about what the value for f of x could be? It could come out. It could come out to, depending on x, I could get a negative number. I could get a positive number. I could get a really tiny, small number. I could get a really humongous number. Okay? All depends what x is. The only thing that I can't get, what's the only number that this will never, never equal? 0, right. This will never equal 0. How do I know that? Because I got an 11 on the top. What's the only way a fraction could ever equal 0?
Is it both numbers?
Not both. What's the only way that I could get a fraction equal to 0? If what? This could be any number in the world, couldn't it? Right. The only way this could equal 0 is if the top was equal to 0, right? Is the top ever going to equal 0 on this function right here? No, it won't. So I can get any answer in the world except for 0. And how do we show that? Negative infinity to 0 union with 0 to infinity. Remember, this does not include 0 because it's open here at 0. Yes.
So in fractions,
Guys?
you look at the bottom part of the fraction in order to find the domain.
Well, the reason I look there is because that's where the x is. Yeah.
And then the top one.
And the range, you got to think, okay, if I put a valid number in for x, I could get any number in the world, right? Except for what? For 0. And so that's what you have to think of as fractions. There's a couple things. In order for this to actually become a 0, that has to be a 0, right? In order for this to actually be a fraction that's a legitimate fraction, What has to be true about the denominator? It has to be any number except for 0, right? The denominator can never be 0. All right, let's do another one real quick. We got about 5 minutes. Is there anything else on there that takes a little bit of work? Those actually didn't take much work at all, did they? It was just a matter of understanding the concept of what you're trying to do and that kind of thing. Is there anything on there? Distance, midpoint, equation of a circle, whether something is a function or not. What else did we talk about? Whether it's a right triangle, whether it's collinear, any of that stuff. Number 5. Okay, distance and midpoint. Let's do number 5 real quick. So number 5, let me put the points, is 13. Oh, wait a minute. It's 13 square root of 10. There's no comma there. So it's 13 square root of 10, comma, negative 16 square root of 2. And then here's another point. It's 11 square root of 10. Now this is a point. It's a point on the graph. Okay, it's an ordered pair. 2 ordered pairs. And 2 ordered pairs make up a line, don't they? And if I connect those 2 ordered pairs, I get a line segment. And they're asking you to do 2 things. They're asking you to find the distance, the length between those 2 points. And they're also asking you to find the midpoint. Okay, what point is halfway between these 2 points? That's what they're asking for. 2 different things. Everybody see that? So let's do distance formula. Again, you need to know these formulas. If you don't know these formulas, again, I hate to be harsh, but it's your fault because it's just a matter of memorizing them. Okay, write them down 10, 15 times. Okay, or do 10 or 15 of these problems, and I guarantee you'll memorize the distance formula. So here it is. It's just like Pythagorean theorem. So what do we do to find the distance between these 2 points right here? We subtract them, right? So we subtract the x's. Now watch how they made this nice and easy for you. You may think this is super crazy because you got all those square root things, but they made it easy. 13 square root of 10 minus 11 square root of 10. Well, 13 minus 11 is 2, and it's just a square root of 10. Right? It's simple to subtract those. Let's do the y's. Negative 16 square root of 2 minus negative 14 square root of 2. Minus a negative is what? Right, minus a negative 14 is the same as plus. What's negative 16 plus 14? It's negative 2, what? Square root of 2. All right, that wasn't that bad, was it? Let's do this. Let's square this thing. If I square 2, I get 4. If I square the square root of 10, I get 10. All right, let's do this. If I square negative 2, I get 4. If I square the square root of 2, I get 2, and they're being multiplied. All right, I'm showing you every little step. Some of this you could probably do in your head. What's that? 40 plus 8, square root of 48. And you can leave it like that. I'm letting you leave it like that. But I'll show you why they wrote it the way they did. 48 is the square root of 16 times 3. The square root of 16 is 4, square root of 3. So that's the simplified way, but I would completely accept this right here. Let's do the midpoint formula. Midpoint formula is even easier. Midpoint formula, you add them up and you divide by 2. So this time you add the x's and divide by 2. 13 plus 11 is 24. 24 what? Square root of 10 divided by 2. Let's add the y's. Negative 16 plus negative 14. Watch, it's negative 16 plus negative 14, which is negative 30 square root of 2 over 2. Simplify it. 2 goes into 24. 12 times. So it's 12 square root of 10. Look, simplify that. That goes into that 15 times, or negative 15. So it's negative 15 square root of 2. That's the ordered pair. That's the halfway point between these 2 points right here. It's really simple. Just add them up, divide by 2. Now look, in a real world situation, would you really do that? Would you really use numbers like square root of 10, square root of 2? No, you wouldn't. In a real life situation, you probably use decimals and stuff like that and calculators. But the point of this is to make sure you know how to find the midpoint, know what the formula is, and know how to use it. And that's how you would do it. All right? We are going to take a quiz first thing tomorrow. No more review. So the quiz tomorrow is going to be 3-1 and 3-2. All right? And I think there's 10 points, so it's going to, or 10 questions. So it's a little bit of a longer quiz, I believe, if I remember right. I'm not positive, but I think there's 10 questions on it. All right, so be ready for it. Please be prepared. We're going to do the quiz, and then we're going to start a new lesson tomorrow. All right? Now, you can hang on to the homework until tomorrow so you can use this to study from. But I will collect it tomorrow. Bring it tomorrow, and I'll collect it tomorrow.